Would you believe it's already day 5 of week 4? Here we are completing our Sidekick project. I'm so happy. I love this project, and I'm now such a fan of LangGraph over the course of the week. We're going to be talking today about tools, and more tools. We're going to be building in the same tool that we know and love already about searching the web, not navigating a browser, but doing the web search. Using the SERPA API that we've used before. We're going to send push notifications because why not? We know how to do that. We're also going to add a tool to use the file system to be able to write files so that we can have our operator agent that we're building, our coworker that we have with our Sidekick, be able to read and write files from the file system. We're going to have access to Wikipedia so that it can look things up. And we're even going to give it the ability to run Python code itself, not in a Docker container like we did before. This time it's just going to have the ability to execute some Python. And so we're really giving it unfettered access to do things on our machine while we watch and while we monitor. And that leads me to a big point. The Sidekick app that we're about to build is an experimental app. It's something for you to work with and to monitor and watch and use it for your own purposes. This is an app for commercial purposes for you to be able to get more and do more with an AI agent at your side. But in doing so, it doesn't have guardrails. It's something which is open to the wild. And as such, it needs to be treated with some caution. And that's the first thing I want to say. Use Sidekick at your own risk. If you're not comfortable with this, if you're not sure about the technologies behind it and so on, then please do remove the Python Repler tool that we'll add. You should remove it, and even remove the online navigation tools until you're comfortable with what's going on and you can watch it. This is an agent that we are allowing to roam free. Now, of course, when it's using the browser, it's using Chromium, the open source version of Chrome, and it doesn't have access to any of our cookies or any of our passwords in a password manager or something like that. So it's not able to do anything like log in, or it doesn't have access to credit cards and so on. And the file manager is within a certain directory, so it can't roam free on your computer. The Python repr that's pretty open. It could run any Python it wants, which would allow it potentially to write something that could do some damage. So you could remove that if you're concerned, but it does seem extremely unlikely. But nonetheless, you need to be comfortable with it. You need to do it at your own risk, please. The other thing I want to say is that the Sidekick app is a starting point. See it as a canvas. I've built something up with some prompts and some tools, and I've discovered that I can make it do great things for me. It actually did some work for me, some real work, some commercial work that I needed to do, and it did it for me and produced a report, and it was something that I used. So it works. It really works, and it can deliver commercial benefit for you and be your own sidekick, let alone building it for other people. So see it that way, but you need to see it as this canvas. It's something which you need to make suitable for yourself. You need to put in the sorts of tools and give it the kind of prompting that you need. When I use it, I find that it sometimes goes awry, and I need to improve my prompts and make various changes to it to keep it on track. And that's what you have to do. It will require experimentation. And if you do so, it will pay dividends. And that's my final point. There's so much opportunity with this. This really unleashes agentic AI. But this is it's like you're building your own Manus. If you find agents like Manus from the Chinese startup that was able to do things like hunt for good rent in apartments and build websites and things, this is like your very own one that you are building and you are controlling. And so you can make it do great things, but it requires effort put into it too, and it will take some investment of your time and experimentation. And so I see it that way, the good and the bad. It's a canvas. It's not a completed product, but there's so much potential. Well, let's get to it. Here we are in Cursor. We're looking at week 4, of course, and now we're going to Python modules, which I know will please some people, but I'm not going to be typing code. We're just going to be looking at it, but going through it carefully. So Sidekick, the application, is divided into 3 Python modules. They are here, and I'll first give you like a drive-by of them. There is Sidekick Tools, and this is the module where we define the different tools that we will use. So it's nicely packaged up in one place. that is going to get us access to a ton of tools, or it's going to give our agent access to a ton of tools. Then sidekick.py. Now, this is a bit of a long module here, and maybe this should be broken up a bit. But it contains a class sidekick, and that has the code that includes our worker, our evaluator, and the building of the graph. And we'll come and look through this. And then thirdly, there is app.py, and that is our Gradio app that manages the user interface side of it. Okay, so with that, let's just spend a couple of minutes on each piece. Okay, so I'm going to start by taking us over to the tools, which we're in right here. So the way that the tools module works is it's just a module that's going to load in all of the tools that we've worked with in the past. It starts with a loading in the .env because we'll need the API keys. We set up a few constants for pushover. We create the Google SERPA API wrapper so that we can use that API. And then we have the Playwright tools. This is the tools for navigating, for driving the browser, taken exactly from the notebook that we were looking at before. We use the async code to start the Playwright instance, and we launch Playwright's Chromium, and then we get the toolkit, and then we return the tools from the toolkit. We also return this browser and the Playwright object itself. And we do that because we need to clean them up at the end of it when it's finished with resources. And this is something that I'm not sure, it remains to be seen whether this is properly cleaning up resources. I'm checking to see it does. Sometimes I see that the Playwright, the Chromium browser hangs around for longer than I was expecting, but I think it does close it down properly. Yeah, we'll see if it ever causes like a leak of browser windows being left open. All right, and then this you should recognize because this is the push notification that we've used many times. It's just a simple function that sends a push notification using requests, using the pushover URL. And then there's also one here that's new. This is get file tools. And this is using the file management toolkit, which is from right here, from LangChain community. And this is an example, again, of one of the things that is so amazing about the LangChain ecosystem. It's so popular, so many people have used it, that there are tons and tons of tools that you can tap into. Now, in week 6, we're going to get very excited about MCP, which of course has taken the world by storm. And MCP is so amazing because it's sort of unleashed the ability to connect together with different tools all over the place. But already people who are part of the LangChain ecosystem have had the advantage of a lot of tools that conform to LangChain's tools format, which in itself it's like a sort of a mini MCP, but just for people in LangChain. And so we can take advantage of this now. We'll have more in week 6, but for now we have access to all of the ones that come in the LangChain toolkit, which includes this file management one, which will give tools for our LLM to be able to mess around in a directory that I'm setting, sandbox, and it will be forced to stay in that root directory. So that's good. And then so I'm going to put together these different tools into this collection of tools here. So we're going to take a push tool. We're going to define a tool around that push notification. So this is like a homegrown tool to do that. There's file tools that we've just talked about. There's a tool to run the SERPA search. So this is, again, us manually creating a tool around the search. There's something called the Wikipedia tool. So we create a Wikipedia API wrapper. We create that, and that needed me to install a Wikipedia Python package in our environment, which I did. And then this tool is able to call and collect Wikipedia pages using Wikipedia's API, which is freely available to everybody. And so that gives our LLM expertise about stuff through Wikipedia. And then I also create here a Python repl tool. Maybe it'd be nicer just to show that separately. Python repl. So this means, this is slightly nicer. This means that we are giving our LLM the ability to run Python code much as if you just typed Python at the command line in one of these kinds of interfaces where it can put in some code and get back the answer. So we're giving it that power. And this is something which isn't sandboxed. So it's unlike when we did this with Crew, when we ran Python code within a Docker container. So it was somewhat insulated from the world. This is not insulated. And so this should be used with caution. And if you're not comfortable with it, then you should comment this out. Just remove it from here. Remove it from these tools. If you're not happy with your LLM being able to run Python code on your computer, I'm especially as I'm using GPT-4o Mini, I'm quite comfortable that it's going to be sensible. And besides, I'll monitor it and be careful with it. So as long as you're careful, as long as you show caution, it should be completely fine. But do be aware of what we're doing there. And if you're not comfortable, if you have any doubts at all, then remove that tool from the list. You have been warned. And you can also, of course, just remove the playwright tools. If you don't like it, just have it return something empty there instead of returning those tools. Okay, so that is our set of tools, all the tools that we want to arm our coworker, our sidekick with. And you can just add more tools to this other tools list. Anything you put in there will just automatically get used by our sidekick. You can just keep putting more and more and more things in there. And you can Google or ask ChatGPT about some of the tools that are in the LangChain tools and the community folders, like community utilities and experimental tools and tools. You can look at these, or you can just look at them on LangChain's documentation. There's a lot to choose from, and you can just put them all in here. You can have a tool that can look at your Google Calendar and attach to Google so that it could schedule things for you. You can have all sorts of tools. There's so many, and that's the beauty of this project, that you can just keep giving more and more capabilities to your LLM, to your agent. That's the idea. All right, next up, we're going to go to the big class, which is Sidekick. So now I've gone to the Sidekick module. Here it is. So the good news is this should all be familiar to you because it's just the same code we had in the lab, just moved into a Python module, which shows how, again, if I can do another of these, like a pitch for using these notebooks, you can iterate on something in a notebook. You can prototype, iterate, perfect your prompts, and then move to a module. And people from an engineering background will say, well, that's not the way that we write software. We have things like TDD. We have a very different kind of process. The thing about this kind of work is that it is much more experimental by nature. The mindset of an AI engineer is more about crafting prompts, trying different ideas, seeing how they work. And so because by its very nature, it is a bit more trial and error, and it means that it lends itself very well to a notebook interface initially until you've got things bedded down. And then you move to sort of productionizing something in Python code like this. So anyways, this is the module. We define the state, the typed dict that is our state. It has the messages field, which is the annotated field that is a list that will use this reducer, add messages. We have success criteria, feedback, success criteria met, and user input needed. These are the things that we get back from our assessment. And talking about our assessment, our evaluation, here is the structured outputs schema, the schema for the output that we get from our LLM. And we want feedback, whether or not the success criteria is met and whether or not user input is needed. That's what we want back. And these descriptions are what will be provided to the LLM so that it populates the structured output. Well, okay, and now we have a class called Sidekick, and it's quite a big one, and maybe this could warrant some refactoring, but it's basically everything we had in the notebook. There's one fussy thing about working with async code, which is that the init method, when we create this, we don't want that to be async. But we need to be able to do some initialization that will be async, like setting up our graph. And so we have to have like a separate async, I'm going to say async method, but a coroutine that is going to be handling that part of it. And we're going to need to make sure when we initialize a sidekick that we can first instantiate it and then call this setup asynchronously. So the first thing I do in this setup is I call that playwright tools function coroutine that we saw in the other in the Sidekick tools, and then I populate my tools, my browser, and Playwright. And then I add into tools the other tools that we also put together in the other module. Okay, and then I create my worker LLM, which is, in this case, GPT-4o Mini, but feel free to switch it up, and bind it to tools and store that as an instance variable. And then an evaluator LLM, and I also store that as an instance variable. And then I call build graph. That's going to be the big part of that. That's what we've always said is the 5 steps that need to happen before you can actually run your graph and do your super steps. Okay, and so what we have now is the worker node that is defined right here, and it's quite long, and it doesn't even fit on one screen. I think I expanded the font size a bit so that, but that does have that drawback. Maybe I will make it a little bit smaller for a second, and we'll make it bigger again in a minute. Go down a little bit so you can at least see it all in one screen. So this here is worker. So it's got a pretty meaty system message, which I have built up based on my experiments, and you will need to keep doing so too. I added in here the current date and time. I actually, for a bit, made another tool to come up with the current date and time, but I realized that then I had to come in here and prompt it to be sure to use that tool. And then I thought to myself, okay, this is silly. I always want it to know the current date and time. I put that in as a tool, and then I'm telling it in the prompt to be sure to use that tool. And that's just such a waste. This is an example of something that doesn't need to be a tool. It needs to be inserted in the prompt every time. It is what we'll call a resource when we get to MCP time, but it's like a piece of information that we want to add in there. So I just shove in the current date and time in the prompt. I had an interesting thing happen when I was using the Python tool, that I saw that for some reason GPT-4o Mini misunderstood how the tool worked and thought that the code it would put in there, whatever that evaluates to, would be what it would receive in the response from the tool, where in fact you had to put in a print statement in that code if you want to actually get back some text. And it didn't do that. So as a result, it was going backwards and forwards, trying to rerun again and again and not getting any results and seeming confused. So I added in this line: you have a tool to run Python code, but note that you need to include a print statement if you want to receive output. And then it started to work immediately. So maybe that's just a GPT-4o Mini anomaly. Maybe if I used the big GPT-4o, it would be fine. It would have figured it out, or it would just know. Or maybe the way that the tool, the description in the tool isn't clear enough, and I could always wrap it in another tool that would make that clearer. But regardless, this fixed it, and this is such a good example of the experimental nature of this kind of work, that you need to be able to come in and just shove something like that in the prompt. Maybe this won't be needed for what you do, but it was needed for me. And there was another example of where I came across something similar. Yeah, you'll probably find it yourself if you look through this. You'll see other times when I had to tweak things to handle some cases. So anyway, other than that, this is all identical to what we have in Jupyter in the notebook. Let me expand here. Okay, and now this is the router, the worker router, the decision, the condition on whether or not the worker should go to tools or to evaluator. This is the utility method that converts our messages into a nice user assistant. And finally, not finally, but the big guy is the other node, the evaluator. And this has, again, a lot of pretty substantive prompting that I have tweaked over time that describes you're an evaluator, what you're there to do. It's got the formatted conversation, the success criteria, the last response, and then responding with your feedback. I remember now I added in this I noticed that the evaluator was quite harsh and never seemed to sort of trust that what the assistant said it had done, what the worker said it did. The evaluator always said, I don't know if this actually happened. So I put in here, the assistant has access to a tool to write files. If the assistant says they've written a file, then you can assume that they've done so. Overall, you should give the assistant the benefit of the doubt if they say they've done something, but you should reject if you feel that more work is needed. So, again, and maybe this time I've gone too far and now I'm going to make it accept too many times. It's something that requires constant tweaking and refinement as you find cases that work or don't work. And of course, it's always good to add in examples, give real concrete examples. And there's some trade-off, because the more information you put in here, the harder it is for GPT-4o Mini to be coherent, because it's just got a lot more information to absorb. Yeah, it's definitely something that I found that giving these kinds of hints and examples has helped me get better outcomes, and you will need to experiment. Okay, so that is the evaluator. We've then got at the end of it, I'll just mention again, remember at the end of the evaluator, we evoke the LLM with output. And because it's one that has structured outputs, which is what that with output means, it returns back an object, an eval result object populated. And then we pluck out the fields of that object and we populate them in our new state. And we return the new state as all nodes. Take an old state, return a new state. And then this route based on evaluation, this is again another of these condition branches. We see whether either the success criteria is met or user input is needed. In either of those situations, we need to end. But otherwise, we're going to bounce back to the worker to give it another shot. Okay, and then here is the build graph. And this, after I made such a song and dance about this in the first couple of days of this week, now this is like the easy part of the whole thing. We create our graph builder for the state of the class that we have created. And then we add our worker, we add our tools, we add our evaluator, the 3 nodes. We add our edges, our conditional edge. This is not a conditional. This is if a tool is run, it needs to come back to the worker. A conditional edge to choose between the worker and ending, and the start going into the worker. And then we compile our graph. Okay, and then I've got this run superstep function, which is the one that actually invokes the graph. So run superstep then is pretty straightforward. I've got the random UUID I've set as an instance variable sidekick ID. So I set up the config this way. And then the state, the initial state that we will use to invoke our graph, it is the message from the user. For the success criteria, it's either the success criteria that's passed in, or if that's not set, if it's null or an empty string, then I use this default. The answer should be clear and accurate. Feedback on work is set to none, and these two are both false initially. And then we call our graph invoke to kick it off. And then we pluck back the user's thing, the user's message, the reply, and the feedback from it. And we construct our history, and that is what we reply. And then I've also got this at the end, like a cleanup function. And as I say, it's kind of, as you'll see, this gets called when resources get cleaned up. And I'm not 100% sure if this is always cleaning everything up. And so over time, I will try and keep an eye on this, and I may refine this as we go, as I get to see whether this is properly cleaning things up. So if it looks a bit different when you're looking at this code, then I might have found a better way to do this that's more reliably cleaning resources after they've been used. And I'm talking particularly about, of course, about the browser. We spawn this headless browser. And the thing to be aware of is, okay, once we've done that, if we then kick off a new sidekick process, it spawns another browser. What have we done to that first browser? Have we closed it? Have we quit the browser that's running behind the scenes or running in front of the scenes, as it would happen? I've put this in to do that. Okay, and now on to the user interface, the app.